If you've ever looked up at the night sky and wondered if the facts we've been taught about the universe are actually, well, true, you are in the right place. Welcome to this explainer. Today, we're about to completely shatter some established astronomical textbooks. We're going to look closely at how the James Webb Space Telescope is actively rewriting cosmic history. For decades, astronomers believed they had this incredibly solid understanding of how the cosmos evolved right after the Big Bang. But recent data? It's turning that entirely upside down. So let's dive into this thrilling cosmic mystery by asking a really fundamental question about the comfortable, accepted timeline of the universe we all grew up learning. Just think about it. What if the assumptions about galaxies forming slowly over billions of years, or black holes just gradually growing larger, were actually incomplete? James Webb is revealing a universe that is far stranger, way more complex, and vastly more mysterious than anyone ever imagined. Literally every new observation seems to raise more questions than answers. Part 1. Rewriting our cosmic history. To really understand the magnitude of what's happening right now, we first need to look at the disruptor itself, the James Webb Space Telescope. This thing represents the absolute greatest leap in astronomical technology since Hubble transformed our view of the cosmos over 30 years ago. And the profound difference between Hubble and Webb really just comes down to light. Hubble gave us breathtaking views, sure, but it relied on visible light, which gets easily blocked by thick clouds of cosmic dust. James Webb, on the other hand, specializes in infrared light. That means it effortlessly pierces right through those enormous clouds that hide newborn stars and faint, ancient galaxies. And because it can capture this super faint infrared light, James Webb isn't simply looking farther out into space. It's actually looking farther back in time than any telescope before it. Because light takes time to travel across the void, when Webb captures light emitted over 13 billion years ago, it allows us to witness the universe in its absolute infancy. We are literally watching cosmic history unfold right before our eyes. Part 2. The first major discoveries. Now, what scientists are finding in that ancient light is actively dismantling our old theories. According to the Standard Model, the Big Bang happened 13.8 billion years ago. So astronomers naturally expected to look back to about 13.5 billion years ago and find really young, primitive galaxies just starting to clump together. But instead, they found unexpectedly mature galaxies appearing incredibly early. We're talking about galaxies that existed just a few 100 million years after the Big Bang, already looking surprisingly organized. So, the absolutely crucial point here is that this doesn't necessarily disprove the Big Bang theory, but it absolutely forces us to rethink how incredibly fast early galaxies grew and matured. These early galaxies contained massive, enormous numbers of stars. They were evolving much, much faster than scientists ever thought was mathematically or physically possible. Researchers are scrambling to explain this right now. Astronomers are debating a few wild possibilities. They're exploring whether stars were just born far more efficiently in the early universe, or maybe galaxies merged at astonishing, unprecedented rates. There's even the distinct possibility that entirely unknown physical processes, things we just don't fully understand yet, played a major role during the universe's earliest stages. Moving a bit closer to home, Webb is also completely revolutionizing how we view starbirths. For decades, astronomers knew stars formed in molecular clouds. These are vast, super dense clouds of gas and dust. But these stellar nurseries are so incredibly thick that visible light just cannot penetrate them. To telescopes like Hubble, they just look like dark, opaque patches in the sky. They were completely hidden from us. But Webb changes all of that. Because it observes in infrared wavelengths, it sees right through that cosmic dust like an X-ray. For the first time ever, we can finally see newborn stars in the earliest stages of formation with extraordinary clarity. We're looking directly at the exact raw materials, those beautiful swirling disks of gas and dust that will eventually form planets, moons, and asteroids. I really want you to remember this number, 4.5 billion. Why? Because over 4.5 billion years ago, our very own Earth and solar system were formed in a stellar nursery exactly like the ones Webb is illuminating right now. Every single image Webb captures of these swirling disks reminds us that our own solar system was once just part of a similar stellar nursery, somewhere out there in the Milky Way. Part 3. Black holes and alien worlds. Okay, these surprises definitely do not stop with stars and early galaxies. Scientists has uncovered another unbelievable mystery hiding in the ancient cosmos. Webb has identified galaxies existing less than a billion years after the Big Bang that already contain supermassive black holes. We are talking about black holes with masses millions to billions of times greater than our sun, existing when the universe was barely a toddler. There is a really stark contrast here. The old rulebook, the standard model, explicitly said that these massive monsters took hundreds of millions or even billions of years to grow by slowly absorbing nearby gas, dust, and stars. Yet, there they are in Webb's observations, already supermassive giants in the extremely early universe. So how could they possibly have formed so quickly? Well, astronomers are actively exploring several theories. Maybe these early black holes formed straight from giant collapsing primordial gas clouds, rather than from collapsing stars. Or perhaps they experienced extreme hyper-accelerated growth rates in those early epochs that we've simply never witnessed before. Throw in unprecedented merging events, and you have one of the absolute most exciting areas of modern astrophysical research today. Now let's pivot away from the edge of the early universe and look at our own galactic backyard, as Webb takes on the study of exoplanets. Just as a quick refresher, exoplanets are simply planets that orbit stars beyond our own solar system. And while we definitely knew they existed before Webb, actually learning what their atmospheres were made of was extremely difficult. Webb solves this by analyzing the incredibly tiny amounts of starlight that pass through a planet's atmosphere when it transits or passes directly in front of its host star. By catching that filtered light, Webb allows astronomers to actually read the chemical fingerprints left behind by different gases in those distant alien skies. It's truly mind-blowing. And Webb has already identified a stunning array of atmospheric compounds. We're seeing water vapor, carbon dioxide, methane, carbon monoxide, sulfur dioxide. Detecting these exact chemical signatures gives scientists unprecedented clues about the climates and the complex chemistry of distant worlds far, far beyond our solar system. Now, to be fair, some of the planets Webb looks at are scorching hot gas giants, where life as we know it is basically impossible. But others are rocky planets sitting right in the habitable zone. This is the cosmic sweet spot. It's the exact orbital region around a star where temperatures are just right to potentially allow liquid water to exist on the surface, given the right conditions. So, the crucial point we really must clarify impartially right now is this. Finding these chemical elements on planets in the habitable zone does not mean we found life. Whether any of these planets actually harbor life remains completely unknown at this point. What it simply means is that we finally have the advanced tools required to properly look for it and gather these amazing clues. Part 4. Are we alone? Which brings us perfectly to the ultimate, deeply human question driving this entire massive technological leap into the cosmos. Are we alone in the universe? James Webb hasn't answered this question yet, but it is currently providing the absolute most detailed atmospheric observations humanity has ever obtained. It is systematically bringing us one giant step closer to answering one of our oldest, most profound questions. I love this quote. Each new image reminds us that the universe is far more complex, dynamic, and mysterious than we once believed. This thought perfectly captures what this explainer has been all about. Webb has forcefully moved us from the comfort of established, rigid science textbooks right into the thrilling, wide-open uncertainty of discovery. Every single time new data comes down, we realize how much more complex and dynamic the cosmos truly is compared to what we once believed. You know, the telescope's greatest contribution might not even be the answers it provides, but the profound realization of how many questions still remain. The more we discover, the more we realize just how wonderfully strange and uncharted the universe truly is. If the very infancy of our cosmos was hiding this many secrets, what else is waiting out there in the dark, ready to rewrite our history all over again? Thank you so much for exploring with me, and keep looking up.